Over the course of these live lessons, we have discussed advanced approaches to modeling very complex problems with generative adversarial networks and with deep reinforcement learning. I'd like to take a high-level view at this time to discuss the overall benefits of these kinds of deep learning approaches and how they vary from how we were doing things in the past. So all of the ideas that I'm going to talk about for the next few minutes are from the illustrious Andrej Karpathy in a Medium post that he wrote called Software 2.0. So let's start by talking about what Software 1.0 is. So Software 1.0 is any kind of software that you think about as traditional, as classic computer programming languages like Python, Java, JavaScript, C++. With Software 1.0, we need to provide very explicit instructions to the computer with individual lines of code in order to have the computer program behave in a very specific way. Software 2.0 doesn't replace Software 1.0. In fact, Software 1.0 provides all of the critical infrastructure for Software 2.0 to run on. But Software 2.0 consists of deep neural networks that approximate functions. So this is like how we had a deep neural network have the theta weights approximating Q star in our deep reinforcement learning, deep Q-learning network. So these deep learning networks have millions or billions of parameters, and they are increasingly proving more adaptable, useful, and powerful than hard-coded Software 1.0. So let's go over a couple of concrete examples in recent years that we've talked about in either these live lessons or my other live lessons. So the first key example is machine vision. This is, for example, having a convolutional neural network for recognizing handwritten MNIST digits and categorizing them. In the traditional machine learning approach, machine vision involved hard coding lots of features, requiring many years of expertise. Deep neural network approaches to machine vision perform better, learn features automatically, and require little to no expertise. In the realm of natural language processing, so for example, movie review sentiment classification that we do in my deep learning for NLP live lessons, the traditional machine learning approach to NLP required many, many years of linguistics expertise and hard coding each language's unique syntax and word meaning into the Software 1.0 structure. With deep neural networks, again, they perform better, they learn the relevant features of the language automatically, and so they require little to no expertise. In the realm of creativity, we have the generative adversarial networks that we created earlier in these live lessons, creating far more realistic fake images than any of the pre-existing traditional machine learning approaches. I recommend checking out an article in the publication Distill called Using Artificial Intelligence to Augment Human Intelligence. This article provides some great interactive tools that demonstrate how, for example, generative adversarial networks can complement human creativity. The final kind of category I want to contrast Software 1.0 and 2.0 in is game playing. So highly complex board games like the board game Go proved completely intractable for the hard-coded Software 1 approach. Now, a single deep reinforcement learning algorithm, AlphaZero, can crush any Software 1.0 approach, and indeed humans as well. So AlphaZero is way more efficient and doesn't even require training data. All it needs to know is the rules of the game. Overall, there are 6 pros that I want to highlight about Software 2.0. The first one is computational homogeneity. So the idea with this point is that typically the individual components of a Software 2.0 approach are the same kind of small, simple algorithm. So we might have millions or billions of rectified linear units within our algorithm. This computational homogeneity has lots of benefits. So one of those benefits is that regardless of the training data that we throw at a deep neural network, the running time is constant. And the memory use is also constant. Because we have this specific kind of neuron, this specific kind of architectural structure, these particular libraries like TensorFlow for deploying them, these algorithms are highly portable across devices. So you can run TensorFlow on Windows, on Unix, on Mac, and on various mobile devices as well. So this makes the Software 2.0 algorithms highly portable. The fifth point is that this stuff is pretty easy. Across these lectures, we have deployed state-of-the-art approaches for machine vision, natural language processing, creativity, and game playing. It didn't require years of expertise. It took hours, maybe days of expertise. The final point is that Software 2.0 simply outperforms traditional machine learning across all of these various aspects that we've approached, and the realm of applications that Software 2.0 is tackling is growing all the time. So that highlights all of the positives of Software 2.0 driven by deep neural networks, but of course there are some limitations today as well. Let's discuss those next.